He has class.
Oh,
Valid.
really?
Do you want to just have him judge of rec?
I mean, yeah, we can do judges recording. Yeah, I don't care.
Alright, cool. That's fine. Alright, yeah. I'll get someone to announce it, and then I can start.
Yeah, because I already defined my position to you already. I'm just taking the skeptic position.
Yeah.
It's fine.
Alright. So I guess I'll just start off by laying out my definition of what God is. So I believe God is just an atemporal, aspatial, creator of the universe with some form of awareness, like intelligence. So
That's right.
obviously,
So an aware, atemporal, aspatial
yeah,
creator. Okay,
yeah.
that's fine.
So I've two arguments, one for its physical properties and one for the awareness. So I'm just going to lead in with the physical properties first. It's just the standard Kalam cosmological argument, which goes: premise one, all things that begin to exist have a cause. The universe began to exist, therefore the universe has a cause. Would you agree with those premises?
I'm not sure if you can state that the universe has a cause. So can you prove that the universe has a source of causality at its throughout its existence?
Well, do you agree that the universe began to exist?
I'm taking the position that I'm not sure. I can we can go over this. Can you prove to me that it does have a beginning?
Yeah, sure. So not only is it understood by most physicists that the universe did begin to exist, if we were to assume the contrary and assume that the universe has always existed, it would be led into a variety of contradictions of what we commonly understand to be the laws of physics, etc., etc.
Such as,
for example, the second law of thermodynamics states that entropy is gained over time within an isolated system, and so the universe, which we commonly understand to be an isolated system, if entropy is gained over time and the universe has existed for an infinite amount of time, we would have an infinite amount of entropy, but we know that's not the case.
well,
Which
the
means
problem. Well, my issue with that is that's only true if you denote infinite time within the observable universe. I would agree that entropy grows in the observable universe, but I don't think that's true for the early universe because of entropic systems. I'm not exactly sure if I agree to that.
Wait, hold on. So you agree that within the current state of the universe, entropy
within the
grows,
observable universe, but there are states of the universe, such as the early universe, which not only do we not know the states, but we do know that the entropic system worked differently, and that's provable via Planck length.
Yeah. So you're talking about the universe at its initial points, so post Big Bang, stuff like that, right?
Yeah, so that would be it's called the Planck difference. Yeah, it's called Planck inflation.
Okay. So you do realize that Planck lengths and the universe's expansion means that, well, you'd agree when I say the universe is constantly expanding, correct?
Well, it's accelerating. Whether that actually means expanding, but I guess we can agree to a middle ground with that it is accelerating.
Yeah, I was gonna say because cosmic microwave background radiation, along with other these redshifts, kind of indicate that it is expanding. But regardless,
well, yeah, that's acceleration. That's the thing is the topic of saying expanding is weird because of infinite space.
Yeah, but regardless, right? So if you agree that because from my understanding of physics, the initial points of the universe, or the points of the universe in which the laws of physics begin to break down, it's the initial singularity point.
That's not even an agreed upon thing. I actually personally, as an individual, I do not agree to singularity theory for the universe at all. There's too much against
it. Such as?
Well, a few of the issues are caused by what we call spatial voids. We have gravity wells that are issues. We have monopolarity issues. There's such issues such as there are natures of causality that don't line up with that idea. So, and also because of how we now know that inflation was rapid and not continuous, that also proves that there was a state of the universe before the Big Bang that had its own temporal and spatial constants.
Yeah, that's completely fine. So when I say that the laws of physics begin to break down, I'm talking about direct observation. So the closer we get to Planck lengths and the closer we get to, the beginning or
Yeah,
like the
the
expansion of the
uncertainty
universe.
principle.
Yeah, there's like, for example, infinite. I think it was infinite density, zero volume, something along those lines.
Yeah,
Time begins to like.
it's infinite density, zero volume, time and space are one constant on the same line.
Okay,
That's like the whole thing.
even if okay, so that's fine. So I feel like you just said that there was a state of the universe before the current universe, which implies that
Yes.
the current universe hasn't always existed. So when you say that the universe has always existed, are you talking about like a cyclical like cycle of universes that just contract and expand and contract and expand over and over again?
I would prefer to align with either cyclical universe or bubble universe, because both of those are entirely valid states that are pretty
Okay,
equivalent.
well, we can talk about cyclical universes first. So I feel like in a cyclical universe, I feel like okay. First, I'll ask you this: what's your view on causality? Would you agree or disagree with the proposition that like root contingencies are um existent, actual, like they can exist?
Can you elaborate as to what that means?
Yeah, root contingency is just something, or the way I define it, just something that begins to exist without a cause, so it just pops into existence.
Um, I think following like quantum mechanics, I could definitely see that at least from some perspective. That yeah, that is an entirely possible thing.
Quantum mechanics. What about quantum mechanics indicates root contingencies?
So, um, there are states in any region of space. There are microparticles that come in and out of existence rapidly in all positions, and that's what generates the uncertainty principle in the first place. And it's a part of wave particle duality. It's a
Wait, sorry,
major part of it, in fact.
could you repeat the first part you said before you said like uncertainty principle? Can you just repeat that?
Oh, it's there are particles that come in and out of existence in pairs and then instantly collide back in together, ceasing to exist, and that's what causes the uncertainty principle.
Yeah, I guess I just denied the fact that they come in and out of existence. So I feel like okay, how would I explain this? Okay, so inductively, right? We can see that things within the real world don't really just pop in and out of existence. I think it's more so just like a limitation of equipment. So we can't necessarily see what's causing these particles to, you know, spawn in
Well,
and out. But we,
that would be not only assumptive, but it does go against some of our, like you could say that it goes against our intuitions of the world, but again, our intuitions of the world are inherently limited. And another thing about these particles is that if they were generated by some force or energy, they would carry forces or energy, which they do not.
where you said that the particles do not carry
They do
force and
not carry
energy.
forces. They are energy in themselves because they are some form of particle, but they do not carry forces. They come in and then immediately collide within a Planck time.
Yeah. So, hmm, okay. So the argument is that if something was to have caused these things to come in and out of existence,
There would be some effect. There would be an
oh,
effect other than these particles just appearing.
yeah, I'm still dubious as to whether these things literally come in and out of existence though. Because from my understanding, it's more so just the fact that we can't perceive what's causing them. Like I understand about the carrying of energy thing, but if we're talking about quantum mechanics, do they don't like I don't know the specific terms, so I'm not too well versed, but I'm pretty sure there's like positrons and like they I don't know, they like react or send energy outwards, which
Oh yeah,
implies that
so that's like entirely different. So that's different from what I'm talking about. A positron is just the opposite of an electron. That's all
okay.
it is. And then when
So when
they collide into pure energy, et cetera, et cetera.
So when you're talking about particles, then what specific particles are you talking about?
I gotta find exactly what they are. Yeah, it's called quantum foam, also known as virtual particles. Um, within
Uh,
any region of space, via the uncertainty principle, which involves the motion of causality and time itself, particles called virtual particles will appear and negate themselves instantaneously. They are called particle antiparticle pairs, and they pop in and out of existence from the vacuum. These particles have a very short lifetime. At the longest, their lifetime is like 10 to the negative 22nd seconds.
mm,
That it's a
right.
super small frame of time.
Okay. So Where should I start? Because I have a few questions. Okay, are you like reading this from a study or is it just like off memory?
Uh, some of this is off memory. I could probably go look for it. It's but we do know quantum foam is directly tied to, general space and time, not like space and time in the universe, but all together. So it's the fluctuation of just space and time entirely, and it's a natural process that things in this measure can come in and out of existence.
Oh, so okay, so all right. I remember what you just said. That. I just want to ask quickly though, or I want to give a quick analogy before I question what you said. Um, yeah. So I still want to double down on the entire idea that just because we cannot perceive the cause does not mean that there is no cause. Obviously, I understand that you're saying our intuitions are limited, but epistemically speaking, all of our knowledge seems to point towards the conclusion that despite us being unable to perceive a cause, that there should still be some form of cause. And um, I don't really know what you mean by the particles don't carry energy at all. Like,
Yeah,
could you elaborate on that?
they do not carry the forces. So the forces are what happens when particles affect things. And
So the particles themselves have no energy.
they are virtual particles. They have no energy, they do not carry energy, and they annihilate each other because they come in pairs of a particle and an antiparticle.
All right. Okay, that's cool. I all right. Let me just ask this then. So, would you agree then? I'm pretty sure you said something along the lines of these things are like I don't remember your exact wording. Did you say interlinked with space and time?
They are interlinked with space and time, as is all like particles, but these are more fundamentally aligned with that and such. In fact, quantum foam may be like there's a load of evidence that all of inflation across the universe is just this quantum foam on a mass scale because of the hyperdense state of the early universe.
Okay. Well, do you think that quantum foam, whatever this is, do you think it could exist uh without space and time? Like in other words, do you think it's contingent on space and time?
I don't think it's contingent on space and time, no.
So you think that the quantum foam has, or you think that like a candidate for this necessary thing could be quantum foam?
Yes. Yeah, if you want to go for that, yeah.
Okay, does quantum foam exist within the universe?
It it can exist inside of it, and as far as we can tell from every measurement, it would also exist outside of the observable universe as well.
When you say outside of the observable universe, you just mean outside of the universe that we as like we can currently observe and know of, or do you mean like outside of the universe as a whole?
The the observable universe is as far into the past and current moment we can detect of this universe we can see, all the way out to where light doesn't pass anymore.
Okay, so you said just to be clear that quantum foam is like a particle and an antiparticle. They appear in pairs and they like mutually annihilate each other. Correct?
Yes, they immediately appear
Um,
and annihilate each other.
and so would you like would you think that this is like a good candidate for like something that could cause the universe to exist?
The observable universe, yes, I think that is a viable candidate.
Okay. So you believe that these pairs cause time and space?
They can very easily do that, yes, if you want to make
Okay.
that argument.
Okay. So I'd like to ask then, uh, why is it that we are unable to like why is it that we are unable to detect time using Planck lengths and etc. etc.
But we can.
Like surely, uh, not that the studies I've seen indicate.
But we have that's what a Planck time is. That's what Planck lengths are denoting. That's also what Hilbert fields and the Hilbert particle, all of those things, like the Higgs boson and the Higgs field, all of those things are measurements of temporal existence. So
Yeah,
I'm
but
not
obviously
sure. Not
there's a
sure
limit
what
to
you
how
mean.
far back in the past we can detect. You know.
There's the only limiter that we have is the ability to see the light as it traveled. That's the only limiter. Like we just had, like for example, the new telescope, the JWST, just it gave us like it jumped us almost 60 years ahead in development of knowledge. So but that doesn't mean we can't measure like time as a constant. I'm not sure what you mean.
As in, the closer we get to the initial like point of the universe prior to its expansion, the more that like I said before, the laws of physics, space and time begin to break down. No?
They become more difficult to measure. They don't exactly break down, but they do become more difficult to measure. With Planck lengths, that's generally true. That like a lot of our measurements become very difficult to use, and there are some answers to that.
Actually, okay, wait. So, can you run me through like your interpretation of how? Because this is like we're talking about the cyclical cycle of the universe. So, could you run me
Yeah,
through your
we could do it.
interpretation of how, like, the first universe came to be? You think like something just popped into existence and
I
caused it?
think just like these pairs come into play, the way that the cyclical universe is done is that there is a state of temporal and spatial existence that has always existed and will always exist. And from that, two uh, inflation states, like those particles, appear, expand outward, and recollide and erase each other. A universe and an anti-universe in a cycle that goes on for any degree of whatever temporal constant we use, because we haven't even addressed things such as anti-causality or reverse causality yet, which is in the universe, regardless
Okay,
of
wait. So, you think space and time has always existed then?
they would like it's the same question as has existence always existed. It would be yes, because space and time is existence. So yes, it has always existed because that is what existence is. That is what being is.
You
Is
think
some
that existence has always existed?
yes.
I
It,
I, I disagree.
oh, so you think existence came into existence? Would that not be contradictory?
I don't think space and time. Okay, I don't agree with your definition of space and time being existence as
Okay,
a whole.
why? What can you give me an example of something that you can denote other than your supposed god that is atemporal and a like spatial in existence?
Um, your supposed particles and antiparticles have to be atemporal spatial.
No, they don't.
So that would mean that they've always existed then, correct?
They again, that follows the whole thing that they can come into existence and cease to exist. Like that's
Which
no problem.
which implies time.
Which is a part of yes, it's a necessary precept of
Wait,
existence.
so prior to it, okay, wait, hold on. So I asked you, do you think
Existence
space
as
and
a
time?
whole, like all of
Wait.
existence.
I asked you, do you think space and time have always existed? You said yes.
Yes. Yes,
Okay,
because
so
they are one to one with existence. Like space
yeah,
and
so
time, like space time, they're not actually separate things. Actually, that's one thing I have to address. Space and time are not separate things. They are the same object of like reference. They are the same
okay,
thing.
wait. So what was the first entity or the first thing in your universal framework?
There doesn't need to be a first thing. There can just be there is the universe that can be both like just a continually existent thing.
No, that's not okay. Wait, so are you saying that the universe has always existed within this cycle?
Yeah, in the cycle, the not the observable universe, but the universe as a whole would have always existed.
Yeah, and I'm asking what's the first like. So wait, when I outlined the cycle, my understanding of it, where I said that the universe contracts and expands in a
Well,
cycle,
yes,
you
I
agree?
I addressed that. I said the contraction and expansion would be two universes appear, expand, and then collide together, erasing each other, and that
Yeah,
is
if
the
they
process.
yeah, if the universe has appeared, that would mean that there's a point in time where they were not there. In order for them to appear, that means they have not always existed, which means space and time haven't always existed.
But space and time exists outside of the observable universe. What that doesn't like matter. Like
Space and space and time can exist outside of the. Wait. I don't see how that defeats my point. I'm saying, okay, look, I'm saying that the very first pair, right, under your universal framework, there's a universe and an anti-universe, for example. They spawn in, right? If they spawn in, that means that there was a point in which they were not yet there. And if they had always existed, which is why I'm trying to like understand, how did that pair always exist, or was there a point where it just came into existence and then annihilated each other, whatever? Because I
I'd,
feel
I'd
like
I'd say that there can be any number or like at every point of time there is universes coming in and out of existence at every possible point of time you can denote, which would be that these pairs always existed, and they will always continually like create and destroy each other at every possible moment of time.
Yeah, I think that's contradictory. Then
How is it contradictory?
how can something always exist, but then also, or how can one thing exist and then also simultaneously come into existence? It doesn't make sense to me. It's
Because there's
unintelligible.
infinite values of those universes. What's the problem with having that set?
So you're saying that? Wait, no, you're not understanding me. I'm saying that the very first universe, okay? Because I'm trying to see the like.
There can't be a first if there is a temporal recursion. There can't be a first. I'm not like you're not like actually.
Wait, so are you saying there's an actually infinite amount of universes?
There would necessarily need to be under the cyclical framework. There would need to be actual infinite, or else the system doesn't make sense. None of the
Yeah,
math
okay.
and the science for it makes sense.
I feel like actual infinites are unintelligible.
Okay, why?
Actual infinites. Are you aware of like the Zeno's paradoxes and etc. etc.?
The what paradox?
The Zeno's paradoxes. Like, okay,
I'll let you elaborate on them.
so contextually, I'm pretty sure Zeno was like uh, a proponent of some sort of belief, and in order for this belief to be true, he had to prove that change didn't exist. So he like made a variety of paradoxes, such as like Achilles and the tortoise. I think he made one about an arrow. Like if you look at an arrow through each individual point in time, it's stationary,
Yeah.
so how can it be moving? Stuff like that. So if there was an actual infinite number of divisions that were possible at any given moment, I don't see how you can get from one point to another, which is change. I don't think that would make sense.
It's interesting because from what I know about Zeno's paradoxes is that they have faulty logics embedded in them in the first place.
Such as?
Well, we can talk about this. We can talk about the solution to some of his issues. For example, we have a distance of 10 meters, and then it just keeps getting halved, and you always approach a deeper half of that notion. If you do this mathematically, you take the limit of n as n goes to infinity, you find out the limit body, and then you divide by 2 because that is the metric of how it's being divided. And now you have the limit of s to n equals 2 as n approaches infinity. So it can be reassembled to give the desired finite answer instead of leading to infinity. And that's like the most famous one of his paradoxes. It gets really easily solved by just simple calculus. That's at least the Achilles and the tortoise. That solves the Achilles and the tortoise. And there's like indeterminacy and discontinuity. The small problem with that, his entire argument for that, is that it assumes time and space to be separate objects, which, as we know, and as you had for earlier corroborated, that they are the same structure. And that means his definitions and usage of argument are entirely wrong. And even if you further on to Einstein's train, there are still solutions to all of his mentioned paradoxes. Every single one of his paradoxes has a mathematical and finite resolution, meaning his usage and defining points of actual infinity and his arguments for why it cannot work are all fundamentally flawed.
Okay, so I don't think you understood where I was going with the actual infinites point. So that there are solutions, right, to how Zeno's paradoxes, or like solutions to the paradoxes in itself, and prove that, like, oh yeah, they're not actual infinites, right? But if they were actual infinites, then obviously there would be a contradiction. If there was an actual infinite,
the function of the actual infinity is sustained, which means the value of the answer is still has an actual infinite value attributed into the equation, but the answer doesn't produce the paradox that was originally described.
when I say actual infinite, I mean like an actual infinite set of things. Does that make sense? So
Yes.
if I was trying to walk from point A to point B, but there are an actual infinite number of steps between point A and point B, I cannot reach point B. Therefore, there is no change, there's no progression, there's no development, right? I'm not moving anywhere. So the reason why I brought this up was to link this back to an actual infinite set of universes. If there was an actual infinite set of universes, how would we reach from, I don't know, a prior set to, or not a prior set, a prior universe to our universe if there's an infinite number
Why
of
would we
universes
need
that
to?
separate us?
Why would we need to?
I'm not
Just
saying
to
it's we need to. I'm not saying it's necessary. I'm
Okay,
just saying that it poses a
then if we
contradiction.
don't need to, then that's not a contradiction. If it doesn't matter, then it doesn't matter. It's that simple.
No, I'm saying that, okay, you're not understanding. When I say that, I'm not saying that it is necessary, right? I'm
Then
saying
why
that,
does it matter?
why does what? I'm so confused.
Then
Wait,
why
repeat
does
yourself.
this supposed progression of change matter if it's not necessary?
Because you're entailing, or your argument entails that there is change that is occurring.
No, it doesn't. Why does
The
it
fact
entail
that we're
that?
going,
Why does it
the fact
entail
that we're
that?
going from universe 1 to universe 2.
There is no universe 1 to universe 2. I never asserted that. You're asserting that for me.
So wait, hold on. So the
There
fact
can
that,
be like the progression of causality is something we measure in the universe, and we know that there are objects both in and out of the universe that do not follow our standard causality.
objects in and out of the universe,
Do not follow standard causality. Do you know what anti-causality is? Do you know what reverse causality is?
not at all, no.
Okay, so in regards to a system, let's call our discussion a system. There's the causality of we started a debate, we give points, and those are events that have effects, and we lead to the end. There is different values of causal systems. There is more than just our traditional cause and effect. There is acausal systems that is any system that does not that an acausal system is a system that is not a causal system. It is one that depends on some future input values and possibly some input values from the past or present, at least relative to in the universe. This is in contrast to a causal system, which depends on only current or past values. And that's just how we denote normal causality.
Wait, did you say that there's a form of causality that is dependent on future
No,
values?
acausal systems is not a causal system. It is the opposite of a causal system, where it is dependent on the future values.
Can you give me an example of an actual acausal system?
Sure. Let me go ahead and grab this. I'm gonna go grab not only a PDF on it, but also explain it. A causal, where is it? A causal phenomena in physics and biology, causal ontology of objects, causal relations, abstract objects, and then, where is the Laplace transform? Causality. Where is... I guess I'll have to send this because I can't find the book on it. Oh, there it is. Where should I send this, by the way?
Scans.
Sure. All right, cool.
Because to me, that entire like acausal um causality or acausal entities, whatever, it sounded quite unintelligible. Because from how I understand, anything that's subject to causality is contingent, right? Like, okay, under our basic framework of causality, which is just like cause and effect, something you'd have to be contingent in order to be caused, right? So, in order for this to be the case, you'd have to be dependent on a current state of affair. I don't see how something can exist and be contingent on something that does not yet exist. It's like it doesn't make
Yeah,
any sense to me.
you can say that it goes against your intuition, but that doesn't mean it's wrong.
No,
That's
like it's logically incoherent.
Yeah, you can say that. There are other forms of logical like values other than classical logic, so I'm not here to like say here or there for that. I don't really and none of that matters to me.
Yeah,
But
no,
here I sent some
okay.
links about the Laplace transformation, which is the function of how space bends and how that requires anti-causal values. I sent a link about the causal ontology of object causal relations and how they relate to anti-causality. I sent a link to JSTOR, which is a talks about acausal phenomena, and it is a book about featured articles and all that such, and about anti-causality. And I also sent a link about how the Laplace transformation works, and it's a public course that you can go read the entire course if you want on your free time. But there you go. We do have anti-causal systems within the universe, which is a form of non-causal system reliant on future values of this quantum phone that I was talking about earlier.
Okay, so what I was trying to get at with the logical incoherency was simply this, right? So, like I said, if something is contingent, right, or yeah, if something is contingent or caused, right, causality is just anything that causes something to exist. So, if something is contingent, that thing also has to exist. How can I don't like? Can you explain how? Like, what's the
Can
process for
you
being
denote?
contingent on?
I have a question. If we were
Yeah, if we were to what? Sorry.
Sorry, that was my apologies. My cat unplugged my microphone.
That's fine. All right.
Okay,
Yeah, go ahead.
so if we were to look at let's call we're gonna break this down to like a really bad level. I hate doing this, but let's say we have time as a line, right?
Yep.
How can you say that something at one point exists at this point and something at a later point cannot exist and have relations between each other? Why can they not have causal relations, even though they both exist on the same constant? Because
Uh,
the only argument you would be able to suppose, at least from my end, is that you would just intuitionally argue that your own presupposition of how you experience time is how time functions. And again,
no,
I
no.
just sent scans that kind of go against that entire notion. So
I, I don't see the scans, but my response to that would
I
just
sent them
be,
in tournament scans.
oh, in tournament scans. Okay.
Yeah, that was the
Okay.
chat that I was told.
Yeah, I'll look at these really soon. But my response to the time as a line analogy would just be, let's say that at point A, you have like, I don't know. Let's say that you have a machine or like a generator, and then you have like the sun, right? And let's say that the generator is contingent on on the sun to exist. So without the sun, the generator cannot exist. It's like a logical impossibility. It needs the sun to exist. It's necessary. If the generator, if the generator's existence precedes the sun, and yet you're trying to posit that there can still be causal relations to the sun that does not yet exist in actuality, what exactly is what exactly is connecting these two? I don't understand how something that is existent can be connected to or binded to something that is not yet existent. It doesn't. Can you give me like a? Actually, already have, but to me,
I like again, like I've already given my examples, and if you want physical objects that are examples, okay, we've got neutron stars, we've got black holes, we've got singularity points, we've got monopoles, we've got length, we have temporal wells, we have gravity wells. I can continue. They all fuck with causality in very odd ways, especially black holes. They very
okay.
much
So
fuck with causality.
how are black holes contingent on things that are in the future?
Okay, let's talk about it. So, do you know what happens when you approach a black hole?
Um, time and space bend, like time dilates.
Okay, but do you know what that entails? At least in a physical system. What does that mean?
You can explain it to me.
Okay, so if we were to have a chart, right? We know time and space are the same field. So we're going to put them as like a plane. Like imagine a 2D plane with like, the lines and the numbers, one to like whatever number you want. It doesn't matter. All right, you have that plane. And we'll say that y-axis is time and the x-axis is space. And when you go near a gravity dense object, it bends it basically forward. So the y-axis starts to bend towards the x-axis and the x-axis towards the right axis. In a clockwise or counterclockwise matter, it doesn't actually change much. The closer you get to a dense object, the more it bends. And the reason a black hole has an event horizon is because you will, once you hit that event horizon, space and time have been bent so far by that Laplace transformation that I mentioned earlier, which I have scans for and how it works and messes with causality. It bends space and time to such an extent that the current notion of space is now the current notion of time, such that the center of the black hole is no longer a location in space, but an inevitable future in which you could never avoid. And the black hole contingently exists in that future state because it bent space and time so far that time, which is causality, is bent into a state that it does not function naturally. And if you want scans for that, I can get a plethora.
Okay, so to try and summarize, just so I'm understanding what you're saying that the closer you get to a black hole, the more that time bends
The more
towards
that
space.
causality gets bent, yes.
And then you're saying that because of this, So what part of the black hole is continued on the future? Sorry.
The just the center of the black hole, which there's two different types of black holes. Neither one matters. They're both hyperdense gravity wells. That's all that matters.
Yeah, I'm. Can you like clarify on how it's continued on the future one more time?
Because again, the center of the black hole, which exists to mean, like for example, me and you, we're standing in a room, and there's a black hole in front of us pulling us in. Okay, to us, it exists in the present, and it is a location in space. But the moment we cross the event horizon, the center of the black hole doesn't exist in the present. It exists necessarily in the future. And like, if you are moving through time, you are moving towards things gravitationally through time. And once you cross the event horizon of a black hole, that becomes the future. That is no longer a present object, nor is it a present thing. It is something that exists in the future and is pulling you through time towards it. And you will inevitably reach the center and be informationally erased into pure Hawking radiation, and nothing of you will ever exist ever again.
All right. So you're saying that this thing no longer exists in the present; it exists in the future, right?
It exists as a future event that is necessary to exist, which means it's contingent. Something in the past is contingent on the future.
When I say, hold on. When I say contingent, I mean it relies on this thing in order to
Yeah,
exist.
it relies on the black hole obviously relies on the core and cause of the black hole, which, as I just explained, exists in the future. It doesn't exist in the present moment. Only the event horizon exists in the present moment. Anything past the event horizon exists in the future necessarily.
I don't even. I even wait. Okay, so the reason as to why it exists in the future is because and
Yeah,
causality gets bent. Is that what you said?
time and causality are identical constructs. Time and space are relative to identical constructs, and black holes and mass and energy bend space and time, and therefore causality. And there's a lot of cases in the universe that causality does get distorted enough that you develop an anti-causal, or extremely debatably an acausal system, which personally I think acausality is a mess to talk about. But anti-causality isn't, because it's quite literally proven by all of our physical models. Like Einsteinian cosmology, Stephen Hawking's cosmology, even Newtonian physics accepted that there was some form of anti-causal value.
All right. Well, how does this? How this? Okay, I understand what you're saying. I'm still a little bit iffy on how this remedies my issue, which is that okay.
Well,
I'm pretty sure.
that just means that your standard like concept of causality that you're trying to apply to the potentially actual infinite value of sets that I have doesn't actually debunk it. Also, you can have an actual set of objects that are actually infinite as long as you don't define it as a set of all sets, because yeah, you can just define it as a universe of sets, which is what I would do, and that's what I am doing. So I'm just going to sustain that.
All right. Okay. Wait. So you said that this cycle of the universe would just be what has always existed. So an infinite set of universes has always existed. I didn't come into existence.
Yeah, it's the same way that energy works. Do you know the law of energy? How much energy in the universe is there totally?
I know that it stays the same.
Yeah, it stays the same. The energy constant in the universe stays the same. Do you want to know why? What the total energy value of the universe is?
Sure.
It's 0. The total energy value of the universe is 0 because of anti-energy. And the same thing functions for the entire universe, as we would agree that like matter and energy and gravity and the forces, they affect the entire universe, regardless of what we would say. So
Okay, wait. So if this infinite set has always existed,
and will always
then
exist and will always equate to an absolute infinite, which you could also say is a null value. But yeah, continue.
so then this infinite set is therefore necessary then, right?
Yeah, you would say that it would be some sort of necessitated existence off of this argument if you wanted to go down this route.
Okay, and that would mean that it's not dependent on any state of affairs. It's just
It's
ontologically
not
independent.
dependent. It's not. It would be actually. I would argue it would be ontologically simplistic rather than ontologically independent, which are similar ideas. But ontological simplicity means it is the most simple object, cannot be broken down any further, and has and will always exist because all other things rely upon it to exist.
Okay, so all right, cool. Let me think. So, okay, they've always existed. You're saying that there was never like a first universe in this cycle.
Well, there was no first state. There's no end state. If you have an infinite set, draw a circle. There you go. There's your timeline. Have fun trying to find the start and end because there isn't one.
Mm-mm-mm.
And this personally is just one of many arguments I could be using, but this is probably the best one that I
Wait,
use.
an infinite cycle of universes that's always existed would imply that since the universe is space and time, or is inclusive of space and time, that would imply that space and time has always existed in some manner or form, right?
Well, yeah, I already addressed that. I think
Um,
space time and existence are equivalent terms. Like something does not exist unless it is spatially and temporally present. So to exist, you must be spatial and temporal. So yeah, that's part of the argument.
all right, would you like to conclude then?
Yeah, sure, we can conclude.
All right, so I'm not gonna lie, I go beat up badly. I go beat up badly. But basically, my argument was just that things that begin to exist require a cause. I used induction. He said that my induction and my intuitions would be limited. Um, I then explained, or then he then explained and started talking about like stuff like anti-causal systems, whatever, uh, quantum mechanics and stuff. Um, he then said that this like infinite cyclical set of universes would just be necessary, etc., etc. So I was just like, ooh, yeah. And then I was just like, all right, that's fine. Um, I chose to conclude because these are both like they can both be candidates. Like the existence of these quantum fields are just like a counter for or against the version of God that I'm positing. It's not necessarily like a debate. I don't know how to explain it, but
It would.
I'm gonna go into
I
my
would say that my conclusion would be that yeah, yours is definitely a possibility, but not only is my possibility more founded, but also mine denies yours as a possibility, which you did not have a like an actual denial of my possibility, which
yeah.
means I sustain.
That's when the second argument I talked about comes in.
Yeah.
So do you want to get into that now?
Um. I'm not sure if it would be like necessary because like I don't think that like judging by this, you haven't really addressed the fact that for not only for something to exist, it needs to be spatial and temporal, but also you haven't really gotten rid of the whole problem of this is a necessary ontologically simple existence. Like, we can't move on to if a creator is aware if there isn't proof that there isn't a creator on your end. So I think if we're going to conclude here, we're just going to conclude the debate. So I think I'll that's my conclusion is with that little
Yeah,
conversation.
that's cool, bro. That's cool.
All right.
Good shit. I'll send direct to you.
Betelgeuse. Yeah, Betelgeuse. He came back. He's here.
Oh, for sure.
All right. I'm gonna dip into the normal VC now.
Me too.
My dick stink, bro.
You niggas is on fucking
I
nerds.
left the
Oh
mid
my
debate. It was
god.
so boring at mid.
Who cares? Go away.
That was the most normal debate I ever seen on the call.
I try to keep my debates as calm and
was-
very controlled as I can.
It was uniquely
Yeah.
shit.
Bro, that's crazy. Anyways, I'm
Damn,
gonna
that's
keep
hating.
this OBS. I'm gonna keep this OBS file for myself. My own argument.